Hey, welcome to lesson number 1 for transformations. In this unit, what we're going to do is we're going to look at what happens if we have a function or a relation, and if we perform a specific operation on that function or relation. Now, this is something that we looked at in Pre-Calculus 11, and we will just continue to develop our understanding for transformations. All right, so when I'm talking about performing an operation on a map or on a function, so what we're talking about is how would we move a specific function. So for example, if I was working with a function f of x is equal to x squared, and if it's that's going to be a parabola, but if I have x squared plus 3, that's going to move my parabola up. So my values of y will move upwards. All right, so let's look at a few examples of transformations. So what we're going to do is compare the three graphs. We're going to compare y is equal to f of x, y minus k is equal to f of x, or y is equal to f of x plus k. So we're only working with two operations, with adding and subtracting. So let's complete the table of values. The first one has already been completed, so this is my parabola on this side here. Now if I have y minus 3 is equal to x squared, so this is in the form of, so y minus 3 is equal to x squared is in the form y minus k is equal to f of x being x squared in this case. Now what would happen if I rearrange this equation to equal y? If I have y minus 3 is equal to x squared, if I were to equal y here, then this negative 3 would come over here, and I would be left with y is equal to x squared plus 3. Now, you might recall from Pre-Calculus 11 what happens if you were to add 3 onto your function of x squared. So if this being our function x squared, if I were to add 3, what this is going to do is transform and translate my function up, so it starts at positive 3 rather than at 0. And so when x was 0, now when x is 0, instead of it being at 0 like it was with my initial function, it's going to be at 0 and positive 3. So what does that tell me for my y values? Well, if I have y minus 3, that actually means that all my y values are going to increase by 3. So at negative 3, this is now going to be at, instead of 9, if it increases by 3, just like 0 increased by 3, this is now going to be at 12. This will, 4, when y was 4, it's going to be at 7. When it was at 1, it's going to be at 4. And then it'll continue in the same pattern. Now let's do the same thing for this other function, y plus 3 is equal to x squared. Well, I could take the same approach and I could set my values equal to y, in which case I would have to subtract 3 from this side and bring it over to my other side. And I'll be at x squared minus 3. Now, if I am at x squared minus 3, that means that my function is now starting 3 lower than it did before. So now when I'm at 0, I'll be at negative 3. And sorry, I should use a different color pen here. This is a unit where it might help you if you have various colored pens. Okay, so that's where my new function is going to start. And every other value of y is going to, instead of being 3 higher, it's going to decrease by 3 and be 3 lower. So that will be at 6. This will be at 1. When it was at 1, it'll now be at negative 2. And this will be at negative 2. 4 will be at 1. And 3 will be at 6. Alright, so the next thing we have to do, so we have to use this table of values in what we just completed, and then graph each of the functions on the grid. So the first one I'm going to graph is going to be y plus 3. And I'm going to start with y minus 3 is equal to x squared. And so when I was at negative 3, I'm going to be at 12. So 10, 11, 12. And positive 3 was also at 12. Oh, should be up there. ignore that point. And in fact, I'm just gonna white out so we don't get confused there. Alright, so 12, negative 2, I'm at 7. Negative 2, I'm at positive 7. And at positive 2, I'm also at positive 7. At 1, at negative 1, I'm going to be at 4. Same thing on the other side. And I already put my first point on my grid. And this is what my function of y minus 3 is equal to x squared will look like. Now let's look at the next one. At y plus 3 is equal to x squared. Well, I already started down here at negative 2. Or at negative 1, I'm going to be a negative 2. And negative 2 for positive 1. At negative 2, I'm going to be at 1. And 1. At 3, negative 3, I'm going to be at 6. And this function is going to look something like this. Alright, and sometimes it's a good idea just to highlight where your functions are as well, your new functions. And this one down here, I'll label it down here, but this is at y plus 3 is equal to x squared. And I'm just going to highlight beside it. And those are my new functions that have been translated. So in the second table, y has been replaced by y minus 3. What is the effect of this replacement on the graph of y is equal to x squared? Well, if we're looking at this table here, then if I replace y by y minus 3, that translates my values of y and my entire graph, it translated 3 units up, right? So it translates the graph 3 units up. And what happens in the third table if I replace it by y plus 3? Well, it has the opposite effect, right? That translated 3 units down. Translates the graph 3 units down. And so if you look at the sign, if it's negative, it'll go up, and if it's positive, it'll go down. So it kind of has the opposite effect of what you would think it would have. Just like when we have values of x within a bracket, what that does is it moves my graph side to side, either left or right. So if it's positive, it'll move it left. If it's negative, it'll move it right. All right, so for this question, they want us to use a graphing calculator to graph the following functions. So the first function is the absolute value of x. And the second function is the absolute value of x plus 2. And then x minus 3. And so what do you think is going to happen here? It's a good time to pause the video and yeah, just make a prediction of what you think is going to occur when we have these operations acting on our values on our function. Okay, so I'm going to graph just the first one to begin with, and then I'll add the other ones in there. I've already put the equations in, but I don't have a bullet, so they're not going to show up. Now this is something that you should just know what your absolute value of x looks like. Okay, so it just looks something like that. And what do you think is going to happen when I add 2 to my absolute value? Well, I'll do both of these simultaneously. Okay, so the first one that's going to show up is again that one. So what happened was it moved up 2 units, and this one moved down 3 units. Alright, so y is equal to absolute value of x plus 2. It's going to look something like that. And absolute value of x minus 3 is going to look something like this. And this kind of makes sense, right? Like if we were to reverse this and put it in the form of y minus k, then this is going to look like y minus 2 is equal to the absolute value of x. And this would look like y plus 3 is equal to the absolute value of x. So the equation absolute value of x plus 2 can be rewritten. Oh, and yeah, we do it right there. How does the replacement of y by y minus 2 affect the graph? Well, just like we see here, it translates it up. Translates up by 2 units. And this one down here, how does the equation change when we rewrite it as y plus 3? Well, this is going to translates down by 3 units. Now, using the results of parts 1 and 2, so what we looked at on the other page and now this page, answer the following questions. What is the effect of the parameter k on the graph of the function y is equal to f of x plus k? So what is the parameter of k? Well, with this parameter, what happens is it's gonna translate it vertically, k units. So whatever the value of k is, that's is gonna translate it either up or down. So it's gonna translate the value of k units. And if it's plus k, then it's going to be a vertical translation of k units. If it's plus k, it'll be up. In this case, if it's plus k, it'll be up. What is the effect of the parameter k on the graph of the function y minus k? Well, this is also going to be a translation upwards. Translate the value. Same thing. K units, up and up. So compared to the graph of y equals f of x, the graph of y minus k is equal to f of x results in a vertical translation of k units. So it's going to go up. If k is greater than 0, then the graph moves, well, if k is greater than 0, so in this case, if we look back up here, in this case 2 is greater than 0, then that means that my translation is going to go up. If k is less than 0, then the graph is going to move down. Alright, so here's a special note. The notation y minus k is equal to f of x is often used instead of y is equal to f of x plus k to emphasize that this is a transformation on the value of y. Okay, so my values of x weren't changing in any of these situations. It was just my values of y. So the concept of replacing your y by y minus k is very important in Pre-Calc 12. Now let's compare the graphs of, now this is something that's more similar to what you've seen last semester. Complete the table of values of the indicated functions. The first one is already completed. So if I have y is equal to x minus 3 squared. Now, a good way to start is looking at where my 0 was in this case. So at 0 and 0, I started with my parabola of x squared at my origin. Now, if I have x minus 3, what's going to happen to my 0 when x is 0? What is going to occur? Well, remember, if I were to take this out and find out what my p-value is, x minus p, if this is just a standard form of quadratic function, then remember that if it's a negative 3, then this actually moves to the right into a positive direction 3. So when I'm at 0 here, now this is gonna go to, well, actually 0. Yeah, we're gonna stay at 9. And at -1, like these are all these values are going to remain. Well, actually, yeah, all these values are going to remain the same for x minus 3. When x is equal to 0, or sorry, what's going on here? When x is 0, yeah, that's going to be at -9 now. But when x is 3, that's what I'm looking at, and y is going to be 0. Right, because now I'm on this part of my line. I moved from my origin, which was at 0, 0, and I moved that to 3. So now my y values are again going to change. So at -1, I'm going to be at 16. At 1, so basically all these lines are shifting, all these points are shifting over by 3. So if you look at your values of -4, all your values of x's are changing, not my values of y. All your values of y are going to remain the same, but if we look at our values of x, all of those are going to change, and they are going to change by 3 each time. So at -4, I'm at -1. At -3, I'm at 0. At -2, I'm at 1. At -1, I'm at 2. When I'm at 0, I translated it up to 3. All right, and so that's what this operation is going to do. Now, if I'm at +3, what do you think is going to happen now? Well, it's going to go the opposite way. If I look at my values of x, they are going to decrease now by 3 if we compare it to the original. So at -4, it went to -7. At -3 went to -6. But what do you think is going to happen to our values of y? Well, again, our values of y are going to stay the same. So this is going to have no effect on our values of y. They are always going to remain the same within the brackets there. So use the table of values to graph and label each of the functions on the same grid. Well, let's start by doing this function here. So at -1, I'm going to be at 16. So when x is -1, then I'm going to be at 16. So 10, 12, 14, 16. At 0, when x is 0, I'm going to be at 9. When x is 1, I'll be at 4. And when x is 2, I'll be at 1. And then we can just do the mirror image of all these dots here. Okay, so this is what this line will look like. And let's do the other graph, and I'm going to do that in a blue pen. So at -7, when x is -7, I'm going to be at 16. -7 and 16. -6 and 9. -5 and 4. -4 and 1. -3 and 0. And we'll have our mirror image going up. Okay, so this graph is going to look something like this. Okay, so in the second table, x has been replaced by x minus 3, and what is the effect of this replacement on the graph of y is equal to x squared? Well, this, when it's x minus 3, my graph is moved or translated horizontally 3 units up. And what is the effect of the opposite? Well, translated horizontally 3 units down. Right, so it just has the opposite effect. It's affecting the values of y rather than k, and that looks like Chad over there. So Use a graphing calculator to graph the following functions, observing the effects of replacing x by x minus 4 and x by x plus 2. So if I look at, well, what you don't want to do is look at the graphing calculator for all of these. So the graph of square root of x, we kind of know what this is going to look like. It's going to start at 0 and just expand this way. Now if I had a negative x, it's going to look like a sideways parabola, right? But that's not what we're really worried about right now. What we want to look at is just what happens when I translate each of these. So square root of x minus 4 and square root of x plus 2. Well, x minus 4 is going to occur at x when x is equal to 4 and extend the same way as square root of x. And x plus 2, well, I think you can probably guess what that's going to look like. It's going to start over here and then extend the same direction. And so again, it's a horizontal translation. That's what the parameter of x does. It's a horizontal translation. Of, and in this case, we're talking about h of h units. So compare the graph of y is equal to f of x. The graph of y of f of x minus h results in a horizontal translation. And now it's going to ask us the same horizontal translation. And it's going to ask us the same thing. If h is greater than 0, then the graph moves right or up. If h is less than 0, then the graph will move to the left. Okay, so when we're talking about replacements for translations, and by that I mean replacing your variables for your k and your h values that are acting on your x and y values, we can use function notation in order to describe that. So, for example, if we have the function y is equal to f of x, if I replace y, so this being y here, with y minus k, if I replace y with y minus k, that's going to be a vertical translation. Alright, so y minus k is equal to f of x. That's going to result in a vertical translation. If I can also describe this as y is equal to f of x plus k. All I did was I brought the k to the other side. Still, we're describing a vertical translation. Now, with the values, with the parameter x acting on my x value, that's going to be known as h. If I replace x with x minus h, that's going to be a horizontal translation, left or right. And in this case, it's going to be towards the right. And we could also describe that as y is equal to f of x minus h. And still, we're describing a horizontal translation there. So in general, if I have y minus k is equal to f of x minus h, or y is equal to f of x minus h plus k, then your graph is going to move up or down depending on, well, it's going to move up or it's going to move down, right or left, depending on the values of your k's and h's. So if you have a k value that's greater than 0, then your graph is going to move up. If your k value is less than 0, then it's going to move down. And it goes the same with the h value. If your h value is greater than 0, then it's moving right, so positive. If it's less than 0, it's moving left or negative. So let's look at this x value here. Let's see the parameters that are acting on this function. If I have y is equal to f of x, and if the following changes are made to its equation, what's going to happen if I replace x with x plus 2? So what that would look like is y is equal to f of x plus 2. Well, we know that's going to be a horizontal translation. We know that because it's a value acting on my x. Now it's going to be a horizontal translation, but remember, if I take this 2 out of here, that's a negative 2. So that's going to be 2 units to the left. So horizontal translation, 2 units left. Now what I'm doing here is replacing y with y minus 8. So what this equation would look like is y minus 8 is equal to f of x. And we could rewrite this so everything is equal to y. Y is equal to f of x plus 8. And in this case, we know that this 8 is acting on my value of y, so that's going to be a vertical translation. Vertical translation, I can spell here, translation 8 units up. So if it's y minus 8, it's going up. If it's y plus 8, it's going down. So it's kind of opposite of your what's going on here. So this was x plus 2, so it's going left. Y minus 8 is going up. Now if this is x minus 2, then it's kind of acting like a y minus 8. It's going to be going into the positive direction on your Cartesian plane. Now describe how the graphs of the following functions relate to the graph of y is equal to f of x. Well, if I have y is equal to f of x minus 3, remember this is, if I have a value acting on my x value, then that's going to be a horizontal translation. So I'm going to say h translation 2 units to the right. Sorry, 3 units to the right. Now over here, if I were to bring this 4 to the other side, I could rewrite this as y minus 4 is equal to f of x. And I know that this is a translation that is acting on my vertical direction, so it's a vertical translation. And if it's 4 units, or if it's y minus 4, remember that's going up. 4 units up. Now I have 2 translations occurring. I have a value acting on my x value, so it's a positive 10. That means it's going to be going left. So that's horizontal translation. 10 units left, and I also have a translation on my y value, and it's a minus 1. So that's and a vertical translation 1 unit upwards. Now let's examine class example number 3. Well, actually, how about we'll examine class example number 3b. You can do 3a, and yeah, that way it'll just save us all time. So the point 2 and negative 3 lies on the graph of y is equal to f of x. State the coordinates of the image of this point under the following transformations. So we're going to look at this one here. Sorry, this one here. So if I have y is equal to f of x minus 7 plus b, I can rearrange it so I know exactly what coordinates are going to be acted upon. So I have my y value, and if I bring this 5 over here, I know that that's a value acting on my 5. And f of x minus 7, I have a value of 7 acting on my x values. And so if I have the coordinates 2 and negative 3, if I were to move my value of 2 over to the right 7, my new x value is going to be at not 7, sorry, at 9. Okay, so if I move 2 over 7 times, I have an x value of 9. Now my value of negative 3, if I go up from 3 5 times, my new value is going to be at 2. So this new coordinate is going to be at 9 and 2. Okay, so one way we can visualize this is if I have a value of x, and in this case my value of x was 2, if I plug it into this translation of x minus 7, remember if I plug a 2 into there, this is actually going to become x plus 7. And so 2 plus 7 equals 9. And then for my value of y, which was y minus 5, my initial value of y was negative 3. If I have y minus 5, remember that's a translation where I would add 5 because it's going 5 up. And that's where I get my value of 2. So this would be our new coordinate for that point. Okay, so write the equation of the image of y is equal to f of x after each transformation. Okay, so if y is equal to f of x, a horizontal translation of 5 units left. So if I have my value of x, I have 5 units left, so that becomes x plus 5. If I plug that into my equation, y is going to be equal to f of x plus 5. A translation of 3 units up, well, that's my y value. 3 units up would be y minus 3. And if that's my function y is equal to f of x, then I can say y minus 3 is equal to f of x. Or, if I bring that 3 to the other side, y is equal to f of x plus 3. Now a translation of m units right and p units down. Well, m units right, if I'm going right, that's a translation acting on my x value. So it'd be to the right, that means it's negative m. And y units down, that means it's positive y, or sorry, p units down, so it's going to be plus p. So if I have a function f of x, I'm going to have y plus p is equal to f of x minus m. Or another way we can write this is y is equal to f of x minus m minus p, if I bring that p to the other side. Okay, last page. Now on this last page, what we're given are 2 functions. Now, given the graph of the function y is equal to f of x, we want to sketch the graph of the indicated function. So all we're doing really is we're looking at these points on this line, and then we're going to translate them by whatever parameters are indicated. So if I'm at this point, all this graph is telling me to do is to go 2 units to the right. So I'm going to do just that. Every corner is going to go 2 units to the right. So 1, 2, 1, 2, 1, 2, 1, 2, and 1, 2. So my new graph is going to look like this. And this is the graph of y is equal to f of x minus 2. Now, for my other function, if I have a graph that says x plus 3, remember this is going the opposite direction. This is going left. It's going to go left 3 and then down 2. If y plus 2, it's going to go down 2. So at this point, we're going to go 1, 2, 1, 2, 3, down 2. 1, 2, 3, down 2. 1, 2, 3, down 2. And 1, 2, 3, down 2. 1, 2, 3, down 2. So the new line is going to look something like this. And this is y plus 2 is equal to f of x plus 3. And remember, this is going to be written as y is equal to f of x plus 3 minus 2. Okay, the last section is called replacement notation and mapping notation. So the two of them, we don't want to get confused. Do not confuse mapping notation with the notation that we've been using with our replacements up top here. So for example, consider the graph of y is equal to f of x, and it's transformed to the graph of y minus 2 is equal to f of x minus 3. So in this example, the replacements for x and y may be written as x minus 3 and y minus 2. So under this particular transformation, the points on the graph of f of x will move 3 units to the right and 2 units up. The points with coordinates 4 and 6 will then be translated to 7 and 8 because we're going 2 units to the right and 3 units to the right and 2 units up. In general, the points with the coordinates x and y is translated to the point x plus 3 and y plus 2. So the mapping notation may be written as x and y as x plus 3, y plus 2, implying that the point with coordinates x and y is translated to whatever your value of x is plus 3 and whatever your value of y is plus 2, depending on the parameters indicated. So the mapping notation is not the same as the replacement notation. Okay, so this is your replacement notation, and this is your mapping notation. Alright, so the mapping notation is equivalent to the replacement notation, but it's not the same thing. It's equivalent, so they equal each other, but they're not exactly the same. Now let's look at these two examples to kind of flush that idea out a little bit more. So if I say the coordinates of the image of the point -3 and 5 under the translation described by x and y, so x minus 7 and y plus 4, then my x coordinate is going to be, if I'm going x minus 7, that's decreased by 7. Decreased by 7. And if I look at my y coordinate is going to be increased by 4. Now if I input them into, or input my coordinates under these parameters, then my value is going to be -3 minus 7, and then I'll have -10, and then 5 plus 4, because I'm increasing by 4, is going to equal 9. So my new coordinates are going to be -10 and 9. Now write the equation: the image of y of f of x is equal to f of x after the translation x and y is x is decreased by 7 and y is increased by 1. So for my x coordinate, it's going to be 6 less, and my y coordinate is going to be 1 more. And so one way I can write this is y minus 1 is equal to f of x plus 6. Or I could rewrite this as y is equal to f of x plus 6 plus 1.